We've all been there. You drop a huge file into a top-tier AI, ask a question, and get a highly confident, completely plausible answer. Then you look closer. The math doesn't add up, or the summary completely missed the point. When you push a text model beyond its structural limits, it doesn't give you an error code. It shatters silently. The instinct is to take a massive spreadsheet or a 200-page PDF, upload it into the chat, and expect instant, flawless insights. But standard prompting doesn't actually compute numbers or read cover to cover. It processes text through pattern matching and inference. It guesses what the next most logical word should be based on its training. That gap between expectation and reality leads directly to two major failures: hallucinated math when dealing with spreadsheets, and lead bias in documents, where the AI memorizes the introduction but completely ignores the middle. The issue is how we treat the tool. A modular reasoning engine requires specific workflows, not a one-size-fits-all search bar. Let's start with raw data. Relying on text inference to analyze numerical data is dangerous. A wrong number in a financial model costs real money. For small to medium files, you have to explicitly command the AI to stop guessing and start coding. You tell it to open a computational sandbox and write the script. This flowchart maps out the optimal routing logic for data analysis. It all starts with the size and frequency of your upload. If your file is under 30 megabytes, you route it straight into an internal analysis tool. The AI writes Python or JavaScript to extract your answers. But if the dataset is too large or updates continuously, you bypass the web chat entirely. You route it through an API or a local model context protocol server. There is a trade-off here. Running code takes longer, and it burns through your usage quotas much faster, but the math is real. You get guaranteed computational accuracy because the AI is executing a script, not estimating a total. And when you keep massive datasets local using an MCP server, you eliminate context overflow entirely. The data stays on your machine, and the AI acts as the planner. To get professional results from a spreadsheet, stop asking the AI to read the numbers. Force it to calculate them. Qualitative text requires a completely different approach. Shrinking a massive document into a short summary exposes a different set of flaws. The most common is lead bias. The model over-indexes on the first and last few pages, while material facts buried in Chapter 4 never make it into the output. The structural fix is the chain of density prompt. You force the AI to write a summary, identify what it missed, and rewrite it 5 consecutive times, injecting missing entities without increasing the total word count. This chart tracks how humans actually perceive those summaries. We have density on the x-axis and human preference on the y-axis. Step 3 is the sweet spot. The first draft is too sparse, and by step 5, the text is so dense it becomes unreadable. This workflow drains your context window and consumes thousands of tokens, but the result is a fact-rich document that rivals the work of a human analyst. The model you choose for this matters just as much as the prompt. Gemini offers a massive 2 million token window, meaning you can paste in an entire book for ingestion. Claude offers a smaller 200,000 token window, but guarantees superior faithfulness and attention to specific details across that length. High-quality summarization requires intentionally sacrificing speed and token economy to ensure rigorous fact retention. Even with the right prompt and the right model, trusting a single AI output creates massive blind spots. The solution is multi-model consensus. When the stakes are high, you run the exact same prompt simultaneously through ChatGPT, Claude, Gemini, and Grok. Putting those answers side by side immediately exposes hallucinations. You can see exactly where the models disagree on the facts. This becomes critical when evaluating vendor proposals or legal contracts, where audit-grade transparency is required. This is a scorecard matrix using cell-level source tracing. When you click a data point like 99.9% uptime, it draws a direct line to the exact source sentence in the original document. This workflow still requires a human in the loop. You have to manually verify the extraction. You cannot fully automate the final decision. Professional AI workflows do not eliminate the human auditor. They simply accelerate the audit by providing immediate, traceable evidence. How you apply all of this depends entirely on your job and your tolerance for risk. This quadrant chart maps task complexity against setup effort. For a casual optimizer drafting emails, standard chat is fine. Speed is prioritized over rigor. But data analysts must adopt high-friction workflows to guarantee defensibility. Analysts have to accept hitting usage limits faster and spending more time prompting. That is the necessary cost of doing professional-grade work. AI today is a deep collaboration. Stop asking it for easy answers and start asking it to rigorously show its work.